Welcome to Maths with EJD. I'll be making a series of videos on matrices, and this particular video is focused on matrix inversion by Gauss-Jordan method. Before now, we learned about row echelon form and reduced row echelon form. Now, Gauss-Jordan is particularly important because with this procedure, with the Gauss-Jordan procedures, you can actually make a matrix into a unit matrix. And that idea is very important here to make, to find the inverse of a matrix, right? And that is the purpose of this. And to find to find the inverse of a matrix, which is matrix inversion, right, by Gauss-Jordan method, the procedures are just easy, except that the implementation can be quite tasking. Very simple arithmetic, but then it can get confusing, especially if you're under pressure. So the procedure for finding for matrix inversion by Gauss-Jordan method is simply, first of all, you augment the given matrix A with the corresponding unit matrix I. For instance, if you have a 2 by 2 matrix, you just augment the 2 by 2 matrix with a corresponding unit matrix that is also 2 by 2. And then the next thing you want to do is perform row operations on the augmented matrix until this A, the first A here, becomes the unit matrix, until this A becomes the unit matrix. Then whatever I becomes in the process of transformation is automatically going to be your A inverse, right? So augment your given matrix A with the corresponding unit matrix I. And then the next thing is to perform row operations on the augmented matrix until A becomes I. And once A becomes I, whatever I becomes will be the inverse of A. That's your A inverse. Okay, we have an example to take. The first example, which is 3 by 3. You have it here. It's pretty lengthy, but then we'll go through it carefully. Okay, the question is to find the inverse of A, which is a 3 by 3 matrix, 0 minus 3, 1, minus 1, 2, 0, and 3, 1, minus 1 by elementary row transformation. Of course, elementary row transformation is still your normal elementary row operation. So as you can see here, the matrix itself is A, and since it is 3 by 3, the corresponding unit matrix is also 3 by 3. So the augmentation is the next thing. So augmenting the matrix gives, A line I, and then you have the matrix A, and you have the unit matrix I. So you have row 1, row 2, and row 3 like that. So once you do the augmentation like that, now we are going to be using this augmentation a lot, even when we get to solve simultaneous equations, or what better known as a system of linear equations. We are going to use this method of augmentation a lot. Now that the augmentation has been done, we start the transformation process through elementary row operations, you know. So the first, you remember your elementary row operations. One is that you can swap rows. Another one is that you can scale rows. You can multiply through by any number of your choosing, depending on what you want to achieve. And then the number 3 is that you can multiply a row by a particular number and add it to the multiple of another row, or subtract as you wish. So don't forget, in this, just like you learned in um row echelon form reduction and reduced row echelon form, your purpose at the end of the day is to make sure that all the numbers below the principal diagonal are 0. But the interesting thing about Gauss-Jordan is that you want to make the whole matrix, you want to make it into a unit matrix, the original matrix A you are given. So our purpose is to keep going until this whole matrix becomes a unit matrix. And then, of course, while you work on this, the work is also affecting the unit matrix like that. So at the end of the day, once this one becomes a unit matrix, whatever the unit matrix you started with becomes, it will be the inverse of that matrix you started with. So that's a very interesting method. Okay, So we have the augmented matrix, right? The first thing we want to do is that we already know, okay, I mean, this is the augmented matrix. Now we already know we have row one, row two, row three, and we know that the leading terms, the leading entries, which is 1, 1, 2, 2, 3, 3, should actually be not zero. They should be actually a number. And in the case of row reduction, RREF, reduced row echelon form, they have to be one all through. So I'll just go straight for that and make sure we have one there. And that is why here we are swapping rows. See what's happening here. So the first thing I'm doing, the old row two becomes row one. The old row two here is going to take the place of row one, and then the old row one becomes row two. That is just what is happening there. So we have that swapping happening right there. And the reason for that is that we want one up here. So there's zero here right now. So one thing we can do is you can swap two or three. If you swap three, so it means three will end up here and you have to divide through by three. But because there's one here already, and it's negative, so I'll just take this row and replace and put it as row one, and row two, row one becomes row two becomes row one. That is what is happening, and that is what has just happened here. So you see that the new row one now is what used to be row two. So minus 1, 2, 0, 0, 1, 0. And then the old row one is now row two. That's 0, minus 3, 1, 1, 0, 0. So we are very close, although what you need here is one, not minus one, but at least we have started. So now that you have done that, the next thing is that, this should be one. And of course, everything below it should be zero, because in the reduced row echelon form, once you get the leading entry, everything in its column should be zero. It should be the only non-zero thing. If you refer to the reduced row echelon form we did in the last video. So now my focus now, the next operation I'm going to do is to make sure this is one and to make sure this becomes zero. Though it may not be immediately, but at least we start the process. Now for minus one to be one, it's pretty easy. All we just need to do is to multiply row one by minus one. That's why the new row one is going to be negative of the previous row one. So the new row one, this is it. It's negative of previous row one. And what that means is that you multiply every element here through by minus one. So minus one times minus times minus one, 1 minus 2, 0. This is minus one. Then minus 0 is still 0. So that's the first row there. Then, of course, row 2 remains row 2 because we don't have any plan for that yet. So we know what we want to do. We just want to take care of the first column first. So the next thing is to now make row 3 still remains row 3, right? So but then the new row 3 is 1/3 of the old row 3, because once you make this one 1, it's easy to subtract it from you're already anticipating that by the time you multiply this one by minus, you're going to get 1. So you also want to find a way of making this one 1, and the only way to do that is to multiply by 1/3, or to divide by, which is also equivalence of dividing by 3. So as you're multiplying this one by minus 1, you're multiplying this by 1/3, and of course it will affect the whole row. Row 2 remains row 2 because we are still keeping it for future use. So you have 0 minus 3, 1, 1, 0, 0. So you have 0 minus 3, 1, 1, 0, 0. But then 1/3 row 3, that's 1/3 times 3, that's 1. This is 1/3. This is minus 1/3. Then this is 0. 1/3 times 0, 1/3 times 0. Then 1/3 times 1, that's 1/3. So now we have taken care of that. And from this new place, we have 1. So the plan is to make sure this one is 0. But of course, we can already anticipate the next move also. Once this is 1 and everything under it is 0, the next lead entry is going to be this minus 3. So we have to find a way of making it 1 also. And the way to make it 1 is to multiply it by its multiplicative inverse. The multiplicative inverse of a number is the number with which you multiply that will give you 1. So minus 3 times minus 1/3 is going to give you 1. And that is why, so row 1 remains row, now we have new row 1, row 2, row 3 based on the previous operation. But from this now we are going to have another transformation, right? So, and what we are doing here is, this is already 1. So the purpose has been somehow achieved, at least for now. So row 1 remains row 1. And that's why you have 1 minus 2, 0, 0, minus 1, 0. All right. And then we need this minus 3 to be 1. So the way to do that is to multiply minus 3 by its multiplicative inverse, which is minus 1 over 3. So if you it means you have to multiply the whole row 2, the old row 2 by minus 1 over 3. So that will now give us a new row 2 in this place. So minus 1 over 3 times 0, 0. Minus 1 over 3 times minus 1 over 3, 1. Then minus 1 over 3 times 1, that's minus 1 over 3. Same, minus 1 over 3. Others will be 0. So for row 3 now, this one has got to become 0. And of course, the easy way to do that is the new row 3 we are going to have here is going to be the old row 3 minus the old row 1. It will now take the place of new row 3. So the old row 3 is 1. The old row 1 is 1. 1 minus 1, 0. Then 1 over 3 minus minus 2, that's 1 over 3 minus minus 2. That is 1 over 3 plus 2 over 1. The LCM is 3. So 3 in 3 is 1 plus 1 in 3, 3 times 2, 6. So that's why the answer there is 7 over 3. That's why you have the 7 over 3. So the next thing is to say, row 3 minus row 1. So minus 1 over 3 minus 0. That remains minus 1 over 3. 0 minus 0. That's why you have the 0. Then 0 minus minus 1. That's 0 plus 1, which is 1 here. 1 over 3 minus 0. You have 1 over 3. So that way, we have a new matrix again. The transformation goes on. You already know your plan. The plan is to make the original matrix A into the unit matrix. And whatever happens to the original unit matrix is the inverse, as we know. So now this is what we have. So the next thing is, now this one has become 1. We know that in this row now, everything above and below it should also become 0. Of course, okay, I was not normally, maybe if I had done, I could have done make this one 0 at once. But for now, I took a longer route, which I think is not necessary. Normally, I should have taken care of this one. I should have found a way of making this one 1. So I just subtract at once and everything is fast. But it's okay. Maybe the next example I'll be doing, I'll do something faster than what I have here. But it's okay. Now I'm focusing on making, so I've left minus 2 alone. I think I should have done everything together, but it's okay. So this 7 over 3 now, I want to focus on making it 1 so I can easily subtract and get what I need to get. So, and the way to do that is this. Since this is 7 over 3, it's easier to just multiply through by 3 over 7. I have the new R3 now is going to be 3 over 7 of the old R3 so that this one can become 1. So I have R3. The new R3 is 3 over 7 times the old R3 because the multiplicative inverse of 7 over 3 is 3 over 7. Okay. So now I have 3 over 7 times 0, 0. 3 over 7 times 7 over 3, that's 1. 3 over 7 times minus 1 over 3, that's minus 1 over 7. 3 over 7 times this old 0, that's 0. 3 over 7 times 1, you have 3 over 7 here. 3 over 7 times 1 over 3, that's 3 over 7 times 1 over 3. So 3 cancels out, so the answer is 1 over 7. That's why you have this. Okay, so now this one is 1. And we can move on. The purpose is to make this one 0. Like I said before, I should have been proactive enough to make this one go with it. But I mean, no problems. Let's go this way for now. In other examples, I guess I'll be able to, I'll do that and not waste time like this. Okay. So the next thing is that, okay, we have got, okay, I think, have I moved too fast? 3 over 7, of course, 3 over 7 times minus 1 over 3, right? 3 over 7 times minus 1 over 3. That is 3 cancels 3, and you have minus 1 over 7. That is why we have this, right? So all that is done. So now that that is taken care of, the next thing I'm going to do is, of course, this is now the lead entry we are focusing on. This is the pivot, but then this has to be 0. So for this to be 0, right? We can easily subtract. That's why the new row 3 is now going to be the old row 3, the row 3 here minus the row 2 up there. So that is 0 minus 0, 0 minus 0, 0. 1 minus 1, also 0, good. Then minus 1 over 7 minus minus 1 over 3. You know, that's minus 1 over 7. Minus minus is plus. That's 1 over 3. And the LCM is 21. 7 in 21 is 3. There was minus, that's minus 3 plus 3 in 21, that's 7. And then you have minus 4 over 21. So, sorry, you have 4 over 21. 7 minus 3 is positive. So that's why you have this 4 over 21. So going again, you have minus 1 over 3 minus 0. That's row 3 minus row 2. Okay, sorry. It's 0 here. This 0 minus 1 over 3 up here. You get 1 over 3. 3 over 7 minus 0. You get this 3 over 7. 1 over 7 minus 0. You get this 1 over 7, right? And then, now that that is taken care of, we can now, of course, R1 remains R1. That's why I'm not bothering about that. So R1, just repeat it. It's the same. R2, nothing is changing. It's the same because our focus now is to get this one to be 0. Okay. So we have a new set of rows based on that last operation. So the next thing we need to do now is to find a way. So this 4 over 21 now is also going to be a pivot on its own. So this is a pivot. And everything in that column, this 1 over 3 has got to be 0 also. So because of that, now I want to find a way of making this one 1 and make this one 1 also. So row 1 remains the same. Nothing is changing. So, but for row 2, if I need to make row 2, this one into 1, right? Because this one will be 1. This one is also going to be 1. So the new row 2 is going to be minus 3 of the old row 2, because the multiplicative inverse of minus 1 over 3 is minus 3. So I say the new row 2 is minus 3 times the old row 2. That is minus 3 times 0, 0. Minus 3 times 1, that's minus 3. Minus 3 times minus 1 over 3, that's 1, which we need. Minus 3 times minus 1 over 3, that's 1. Minus 3 times 0, 0. Minus 3 times 0, also 0. And then for row 3, right, we want this one to also be 1, 4 over 21. So the multiplicative inverse of 4 over 21 is 21 over 4. So the new R3 is going to be 21 over 4 times the old R3, this. So 21 over 4 times 0, 0. 21 over 4 times 0, 0. 21 over 4 times 4 over 21, 1. Very good. 21 over 4 times 1 over 3. 21 over 4 times 1 over 3. 3 here is 1, 3 here is 7. So that's why this is 7 over 4. 21 over 4 times 3 over 7. 7 goes in 21, 3 times 3. That's why you have 9 over 4 here. Then 21 over 4 times 1 over 7 is 7 goes in 21, 3. So you have 3 over 4 here again. So we have succeeded in making those things 1. So here now we have although this one you have achieved before, you have to take it back to minus 3 to achieve this purpose now. But of course, you're still going to get it back. So this is 1 now, and this is 1. So we can easily subtract. So this is like the pivot in this case. This is the pivot in this case. So, of course, row 1 again remains row 1. Now this one has got to be 0. So, and that is why the new row 2 is the old row 2, minus the old row 3. So that's why you have 0 minus 0, 0 here, minus 3 minus 0. So 0 minus 0. Sorry, I think this should be this way. So the new row 2 is going to be the old row 2 minus the old row 3. So that means 0 minus 0 is going to give you this 0. Then minus 3 minus 0 gives you this minus 3. Then 1 minus 1 gives you this 0. And then, of course, you go on like that. 1 minus 7 over 4, that's minus 3 over 4. 0 minus 9 over 4, that's minus 9 over 4. 0 minus 3 over 4, that's minus 3 over 4 like that. And of course, the old row 3 remains what it used to be, So the old row 3 remains what it was because we don't have any business with this right now. We have achieved the one it needed to be. So we just have 0, 0, 1. The old row 3 is still the new row 3. So 0, 0, 1, 7 over 4, 9 over 4, and 3 over 4. Like that. So now the process continues. it can be really tedious, but you're just doing basic arithmetic. So you just need to be very calm to make sure this is done. So now this is the matrix we just got. So what's the next purpose? The next thing is to make sure that this pivot is the only number in its row, in its column that is non-zero. So every other thing in that column should be zero. So this is already zero. So this one now has to be zero. So how am I going to do that? How are we going to make sure that, so this minus 2 now, sorry, we want to make sure it's 0. And this is minus 3, this is minus 3. So this is the pivot that we need to make this one into 0. So we have to make both of them 1, you know. So row 1 now is going to be minus 1 over 2 row 2 because we need to make this one 1. So, of course, you need this one to be 1 ultimately, but for now, you can trade that so you can at least get rid of this so you can now get back your 1 later. And it becomes easier once this one is 0. So, R1, the new R1 is now minus 1 over 2 of the old R2 because this is minus 2. So, you have minus 1 over 2 times 1, minus 1 over 2, minus 1 over 2 times minus 2. You have the 1 we need here. Minus 1 over 2 times 0, easy, 0. Minus 1 over 2 times 0, 0. Minus 1 over 2 times minus 1, that's 1 over 2. Minus times minus plus, right? Minus 1 over 2 times 0, you also get this. Then the row 3 also, because you need this one to be 1. So what you have to do is to say the new row 2 is going to be minus 1 over 3 times the old row 2. Because this is minus 3. Multiplication of minus 3 is minus 1 over 3. So minus 1 over 3 times 0, 0. Minus 1 over 3 times minus 3, 1. Minus 1 over 3 times 0, also 0. Minus 1 over 3 times minus 3 over 4. Let me remove those red lines so you can see that is those. Yeah. So minus 1 over 3 times minus 3 over 4. That's 1 over 4. That's minus 3 over 4 times minus 1 over 3. So this cancels out. Minus times minus is plus, and you have 1 over 4, like that. That's why this is 1 over 4. Minus 1 over 3 times minus 9 over 4, that's 3 over 4. Minus 1 over 3 times minus 3 over 4, that's 1 over 4. Of course, row 3, the old row 3 remains the same way because we don't have any business with it. This one is already 0, 0, 1 that we need. So this remains what it should be. So 0, 0, 1, 7 over 4, 9 over 4, 3 over 4. So now we have also done that. So that is taken care of. So the next thing we may want to do is to also ensure that R1, the purpose is to make this one into 0. Now they are both 1, so it's easy. This is the pivot, and this is what should be 0. And in that case, since this needs to be 0, we can now say the new row 1 has to be the old row 1, this old row 1, minus the old row 2. So that means we are going to have minus half minus 0, and that will give us this minus half in row 1. 1 minus 1, that will be in row 1. 0 minus 0, that's here. 0 minus 1 over 4, that's minus 1 over 4. Half minus 3 over 4, that's minus 1 over 4. 0 minus 1 over 4, that's minus 1 over 4. And then row 2 remains row 2 because we want it to be 0, 1, 0, and it is already that. So row 2, the new row 2 is the same row 2 as of old. And then row 3 also remains row 3. We have 0, 0, 1, 7 over 4, 9 over 4, 3 over 4. Now, we are very close to our destination. So everything is looking set, except that this first one now should be 1. It was already 1, but we need to trade that off to get this new thing we have now. So, of course, all we need to do now is to get this one to be 1. And easy choice, just multiply the whole of old row 1 by minus 2. So that gives you the new row 1. So minus 2 times minus 1 over 2, that's 1. Minus 2 times 0, that's 0. Minus 2 times 0, 0. Minus 2 times minus 2 times minus 1 over 4. You can say this is minus 2 over 1. So that's 2 here is 1, 2 here is 2. So you have minus and minus plus, that's 1 over 2. So minus 2 times minus 1 over 4, that's 1 over 2. And that's everything here, there is minus 1 over 4. So everything here becomes 1 over 2 all the way. So with that done, you are all set. So it means that now, once you have a unit matrix here, which is 1, 0, 0, 0, 1, 0, 0, 0, 1, whatever you now have here is the inverse of the matrix, whose inverse you're looking for, So now this is your A inverse. because this is now your unit matrix. So, we started with A, I. Now we end up with the unit matrix I and then the inverse by the time you're done with the transformation. So all the transformation goes there, and that is Gauss-Jordan method, Gauss Gauss-Jordan method, and you get this. So you can now write this out. You can now write that out. You now say, so A inverse is 1 over 2, 1 over 2, 1 over 2, 1 over 4, 3 over 4, 1 over 4, 7 over 4, 9 over 4, 3 over 4. And of course, because you see 4 is common everywhere, so you take it out. It's the biggest number as the denominator. So you can just say you have 1 over 4 now. And what that means is, of course, it's just be, for these ones now, you just have 793, 131. But these ones are half, right? So for you to take 1 over 4 out, it means you're more, so it's more like, so 1 over 2 is the same thing as 2 times 1 over 4. So if you take the 1 over 4 out, all this half will just remain 2, 2, 2, like that. So that's your inverse. And then you can say, therefore, the inverse of A is equal to the inverse of A, which is 0 minus 3, 1 minus 1, 2, 0, 3, 1, 1 minus 1 is A inverse, which is equal to 1 over 4 equals into 2, 2, 2, 1, 3, 1, 7, 9, 3. And that's how to do the Gauss-Jordan model. So I'm just going to do something with a 3 by 3 matrix. So imagine that you have, so that'll be example 2, right? The other one, I think I called it example 1, I think it was called example 1, right? Okay, yeah, that was example 1. So example 1. So I do a very simple one, example 2, example 2. So imagine that you have matrix B, which is simply, let me just make something up, 3, 2, 1, 4. Clearly, this one has a determinant, so it means it will have an inverse because the determinant is 3 times 4, 12 minus 2, that's 10. So that means it has an inverse. So, but we want to use the Gauss-Jordan method, right? So in this case, B is 3, 2, 1, 4. And then, of course, the unit matrix corresponding to that will be 1, 0, 0, 1. All right? So now that that is the case, so you augment it. You have B, I, which is 3, 2, 1, 4, augmented with 1, 0, 0, 1. So, and now that you have this, you can now begin your elementary row operation. So first, you want this one to become a unit matrix, and whatever happens to this, it becomes the inverse of B. That becomes B inverse, right? So what is the first thing to do? We need this one to be 1, so we can easily subtract. Then, okay, so let's take care of that first. So this is row 1. This is row 2. So I just say the new row 1, would be 1 over 3 of the old row 1. And of course, the new row 2 will be the old row 2. Nothing changed because we just need to get this one to be 0. And we also need this one to be 0 along the line. So, but let's take care of this one first. So that means 1 over 3 times 3, that is 1. 1 over 3 times 2, that's 2 over 3. And then 1 over 3 times 1, that's 1 over 3. 1 over 3 times 0, that is 0, And then this one remains the same. You have 1 over 4, 0, 1. So now you have a new row 1 and a new row 2. Well, now that that is taken care of, sorry, what's happening here? Okay, I see that now. Okay, all right. So now that we have this, the next thing we want to do is to subtract, right? So this can be 0, okay? So what do? We can now say that row 1, the old row 1 is still this new row 1. The new row 1 is the old row 1. And then the new row 2 is going to be the old row 2 minus the old row 1. So so that this can be 0. So the old row 1 is 1, 2 over 3, 1 over 3, 0. Then the new row 2 will be 1 minus 1, 0, right? This 0 here. Then we have 4 minus 2 over 3. That's 4 over 1 minus 2 over 3. The LCM is 3. 1 in 3 is 3 times 4, 12. Minus 2. 3 in 3, 1 times 2. So this is 10 over 3. Then this is 0 minus 1 over 3. That's minus 1 over 3. Then we have 1 minus 0. That is also 1. Okay. So now that that is taken care of, we can also progress. Now this is row 1 and row 2. And then now what's the next thing we have to do? This one has to become 0 for it to become a unit matrix. And for that to happen, it's better we make the both of them 1, 1 each. So this is the pivot from below. Now this is the pivot, and this has to go to 0. So what do? We make sure those ones become 1. Of course, it is going to affect this temporarily, but once this is 0, it is easy to get this one back to 1. So let's say now the new row 1 is going to be 3 over 2 of the old row 1. So, if you multiply 2 over 3 by 3 over 2, it becomes 1. So that's easy. And then the new row 2 is going to be 3 over 10 of the old row 2, So 3 over 2 times 1, that's 3 over 2. 3 over 2 times 2 over 3, that's 1, easy. Then 3 over 2 times 1 over 3, 3 over 2 times 1 over 3, that is 1 over 2. And then 3 over 2 times 0, that's 0. Then 3 over 10 times 0, 0. 3 over 10 times 10 over 3 is 1. Then 3 over 10 times minus 1 over 3, that is minus 1 over 10. Then 3 over 10 times 1, that's also 3 over 10. So now we have that sorted. So we have that taken care of, right? So the next thing we need to do here is to see, have we achieved our purpose? Okay, not yet. So this is a new row 1. This is a new row 2. And what are we going to do? This has to go to 0. So we can say that the new step is to have 0 here. So it means the new row 1 is going to be the old row 1 minus the old row 2, right? And then we have the old row 2 remains the new row 2. So the new row 2 will be the old row 2 because it's already 0, 1. The unit matrix for 2 by 2 is 1, 0, 0, 1. So it's already 0, 1. So it's more like things are in order somehow. So now we have, so the new row 1 will be the old row 1 minus the old row 2. So 3 over 2 minus 3 over 2, that remains 3 over 2 here. 1 minus 1, that will be 0. We bring that down. Then you have 0, 1 here, normal. So here we're still doing row 1 minus row 2. So now we have 1 over 2 minus 1 over 10. That's 1 over 2 plus 1 over 10. This minus 1 over 10. So the LCM is 10. 2 in 10 is 5 plus 1. So this is 6. So this will be 6 over 10. That is 6 over 10. And then we have 0 minus 3 over 10. So this is minus 3 over 10. So of course, this one remains minus 1 over 10, 3 over 10, like that. So we are almost there. The only thing that remains now is that this 3 over 2 has to be 1, okay? So we have a new row 1 and a new row 2. So we just need to get this one to be 1. So we can say that the new matrix has to be this. The new row 1 would have to be 2 over 3 times the old row 1 so that this can go to 0. And then the old row 2, the new row 2 is still the old row 2. Nothing changes. So 2 over 3 times 3 over 2, that's 1. 2 over 3 times 0, 0. 2 over 3 times 6 over 10, 2 over 3 times 6 over 10. 3 here is 1, 3 here is 2. 2 times 2 is 4. 2 times 2 is 4. 4 over 10, that's 2 over 5. Then 2 over 3 times minus 3 over 10. 3 cancels 3, right? So we have minus 2 over 10. That's minus 1 over 5, you know. Minus 2 over 10 is minus 1 over 5. So this is 0, 1. And here we have minus 1 over 10. And then we have 3 over 10, interestingly. So it looks like we have arrived because now this is unit matrix. So automatically this has got to be the inverse of B, inverse of B. But how do you really know? How do you know? But let me just write that out first. How do you know you are right? That's one thing you may want to ask yourself. I think the simple check is to multiply B by and B inverse to see if that's true. So you can say, therefore, B inverse is 2 over 5 minus 1 over 5 minus 1 over 10, 3 over 10. And of course, I see 10 is the biggest number there. So we can have 1 over 10 into, and if you're bringing 1 over 10 out, so it's more like you have, so, 2 over 5 is the same thing as, so it's the same thing as 10. I mean, 2 over 5 will be the same thing as 10 over 4 or so, you know. Yeah, if you multiply by 2. Okay, let me even do it this way. Okay, yeah, so that should be like 4. Yeah, 4 minus 2. Then, of course, this would be minus 1 and 3. So because 4 over 10 is 2 over 5, minus 2 over 10 is minus 1 over 5. So this is actually the inverse. But to establish if that is correct, you can remember where we started from. We started with 3, 2, 1, 4, 3, 2, 1, 4. Let's see if the inverse we have got is actually correct. So you can say check. We want to check if what we have got is correct. Check. So we have B inverse. B itself is what's it again? 3, 2, 1, 4. 3, 2, 1, 4, yeah. That is the B we started with. 3, 2, 1, 4. 3, 2, 1, 4. And then the inverse is 1 over 10 into 4 minus 2 minus 1, 3. Okay? So let's see that. So that's 1 over 10 out here. And then we have 3, 2, 1, 4 into 4 minus 2 minus 1, 3. Okay? So, and you know the method I taught you for multiplying things out. You have 1 over 10 out here, so you can keep that. 1 over 10 into, so since you have 2 rows here, so you have to write 4 minus 1, 4 minus 1, then minus 2, 3. You write each of them twice, minus 2, 3. And then what do? Bring 2 over 3 over 2, 3 over 2, 3 over 2 over them like that. Then you bring 1 over 4. That's 1 over 4, 1 over 4. Okay? So that is taken care of. So you go ahead and say this is 1 over 10 into 4 times 3 is 12. 12 minus 2. 12 minus 2, that's 10. Then here, minus 6 plus 6, 0. Then 4 minus 4, 0. Then minus 2 plus 12, that's also 10. Excellent. So if you take the 10 inside, you just have 10 divided by 10, 1, 0, 0, 1. So since you have unit matrix here, normally B times B inverse should give us the unit matrix. And since we have the unit matrix, then you can say for sure that our B inverse is correct. Therefore, so you can conclude and say that therefore, the inverse, of B, which is 4, 2, 1, 3, is B inverse, which is 1 over 10 into, that's 1 over 10 into 4 minus 2 minus 1, 3. 4 minus 2, 4 minus 2 minus 1, 3. Okay, on that note, we have seen how we can find the inverse of a matrix using the Gauss-Jordan method. All you need to do is augment whatever given matrix you have. So if you have a matrix M, augment it with I and do row transformation until M becomes the unit matrix, and whatever the unit matrix becomes is the inverse of M. Thank you very much for listening. If you have some advice for me on how to make this better, or you have some questions you want us to treat together, feel very free to let me know. See you in the next video. Thank you.